Welcome to homework.
I created a QQ plot of this really simply in the Decimals graphing calculator. All you have to do is create the list, and then if you label the list in L, and then you can define M as the mean, S as the standard deviation, and then you can just have it plot L, L minus M over S. And what you're looking for is the data to, if it's normal, it should be pretty linear, and the plot does look pretty lined up, which is indicative that it is normal. So do you think it's reasonable to assume that the population distribution is normal? I would say yes, and that's because the QQ plot is pretty linear. All right, now for part B, I'm going to create a 90% confidence interval. Well, the mean is 25.67. The standard deviation is about 8.324. I'll say this is 667, that'll be more accurate. And the confidence interval is the sample mean plus or minus the critical t times the standard deviation of the square of the sample size. So it'd be 25.667 plus or minus, now the critical t, we'll look that up in the student t distribution. Alpha here is going to be 0.10 for 90%. And we would have 17 degrees of freedom because n is 18. And 1.7396. And so our lower boundary would be 25.667 minus 1.7396 times 8.324 over the square root of 18. That's about 22.25. To the upper boundary of 29.08. For part C, if we consider that the null was, the mean is 25 versus the alternative that is not equal to 25, based on our 90% confidence interval, since 25 is within this interval, we do not reject or fail to reject the null hypothesis at the 0.10 level of significance. For part D, test whether these data are strong evidence that the population mean rate is significantly greater than 25 at an alpha of 0.05. Well, that's a one-tailed test. The test statistic is the sample mean minus the hypothesized over the standard deviation over the square root of the sample size. So that's 25.667 minus 25 over 8.324 over the square root of 18. And that's a t-score of 0.34. And that is a p-value Let me go to the distribution. So with a t-score of 0.34 and 17 degrees of freedom, that's a p-value of 0.369. And so we do not reject the null hypothesis for a one-tailed test in this case.